So in this video I'm going to show you how we've taken on a volume calculation over a period of 3 weeks where we did 3 flight surveys, and we're using a combination of the point cloud processor and RPS Volumes Manager to compute and tabulate and generate the results for the project. So we start off with scan data that's coming in from drones. And if we take a look at the scans originally, let's take a look at the first scan, and let's take a look at all the point cloud regions for that scan. Not this one, sorry, wrong one. This one here, 22nd of April. So, sorry, turn all these on. Okay, so we start off with a point cloud survey of the whole site, and in that process what we do is we eliminate the junk areas from this site, which is these areas where there's machines and various other bits of equipment lying around on the site. So we eliminate the junk areas by using the point cloud processing tools. We use the select by polygon, and then we use the add to region, and we create a region called junk for each month, and we take that data out and we put it on those layers. And in addition, we also get rid of all of the data outside this boundary. So we drew this boundary, which is the site limits, and then we use that with the point cloud by boundary command, which is a Rockpile command, to eliminate all the data on the outside. So we end up with basically a clean data set for each flight. So we have, here's the flight data for the 22nd of April, and then if we look at the same data again for the next month, this is the month flight for the 28th of April, and you can see there's some changes going on here. And then if we look at the May the 9th flight, which is this one, you can see that the earthworks has progressed significantly in those areas. And so we process those data down to this limited boundary, and then what we do after that is we run the Rockpile point cloud processor, which is in the toolshed menu here, and we filter this data down, and that creates us these reduced data sets for each week of survey. So this is the April the 22nd data set. If we look at the scan to go with that, this is the reduced data set here. Sorry, not that one. This is the April 22nd data set, and you can see that by running the point cloud processor, where you have breaks in slope or undulating terrain, we keep a lot of data points, and then in these areas where it's flat grade, we get a significantly reduced data set. And so we're taking this data down here. This is about 300,000 points in this data set left, and it started out with about 20 million points. So this is intelligently reducing the data down, keeping the data where it needs to, and that will build you a surface model. If I turn on the April 22nd surface model, this is the surface model that is resulting from that, and you can see that it picks up, the details of tire tracks and stuff. It's picking up all the undulations on the site, but it's giving you a significantly reduced triangle model in areas where the ground is relatively flat and graded, whereas in the areas where it's changing a lot, it's reducing the data significantly. Well, it's reducing it, but it's keeping as much data as it needs to be able to replicate things like these tire tracks, which are deeper than the tolerance that we specified in the calculation. So once we have the surveys for April the 22nd, and then we have the survey for April the 28th, this is the surface model coming up for the 28th, and you can see the ponds have started to be constructed there. And then if we go to May the 9th, that's the survey. Now you can see these ponds are going. And now what we've done after that is we've run RPS Volumes Manager on these calculations, and we store the isopacks for those. So I've created 3 isopacks. One is, this is the net change isopack that shows, if we look at it in the plan view, it shows you the net change between the 22nd of April and May the 9th. And then we have isopacks for each of the week surveys. This is the first week survey, and then this is the second week survey here in the model. And so very quickly we've built out the data, and in process of running Volumes Manager, we've tabulated the results. This is the week 1 survey, this is the week 2 survey, and then over here this is the net change between week 1 and week 2. So I would build tables for each week of survey and then have the net change result as well, so you can see how much total has changed since the start of the project in an incremental basis. And this number here will eliminate double movements of material, whereas over here these numbers will capture material that was moved once and then moved again. For some reason in the model, like if you build a stockpile, then later on you dig away the stockpile and use the material, that's going to come up as a double movement, and this numbers here will be slightly higher than these numbers as a result. Anyway, so we've calculated the numbers, and if we just take a quick look into Volumes Manager here, I go to Modeling and Volumes Manager. Here you can see that we've got the volume calculations done, and here we're storing all the calculated volumes that are being reported in these tables. We can always refresh those if we want to, and we can always come back and look at multiple results. So here we're looking at the week 22nd to May the 9th net change, and here are the net change numbers. And if we go to here, we can go to April 22nd to April 28th, and here's the numbers for that survey. And then if we go from here from April 28th to May the 9th, here's the results for that survey. So as you click on each of these numbers, you'll see these reports will update, and we're storing all of these volumes not just in tabulated form, but also as a kind of a record form inside the model. And any of these data sets you can export to Excel or print a report to PDF from here as you see fit. But over time, we can now build one of these tables for each week of survey and track the progress quantities on here, and then match that up against the data being generated by the guys on site or being generated by the RPS tracker system, which is something you can equip all your hauling equipment and your excavators and stuff like that on site with, and that will allow you to track all of the cycles and loads and get your volume calcs all done automatically within the RPS tracker system if you're interested in looking at that. So here we can break this site down into regions as well. So if we wanted to know the volume changes in certain phases of the project or in certain areas of the project, we could break these volumes down, and then these reports here would be broken down into regions or phases or whatever you might have on the project. It's in this way that we can use the drone flight data on a weekly basis, and we can process the data and then store the running progress of all the quantities that are done on site using those three things. Now, in terms of the volumes, the volume calculations here, I calculated all of these using a grid volume calculation, but when we do an earthworks quantity like this one here, if we go to the volumes calculations and we take a look at one of these, you can change the way that we calculate. So I'm using the takeoff method with a 2-foot grid size, but you can use 3D model using a normal tin or a point cloud tin should you decide you want to do that, and that will work just as well. It's just a little slower to calculate, and to be honest, you're not going to see a lot of difference in the volumes between triangle models and grid models. But anyway, that's how we do the calculations using Volumes Manager, and all this information generated here is all fully automatically reported, and all this data is stored within the Volumes Manager for later recall. And if you want to do stockpile calculations, if you have stockyards or stockpiles on site, then you can run those as additional volume calculations. You can define the boundaries in here for each stockpile, and then make a group of boundaries in here to kind of bring the stockpiles together for different areas of the site. So if you've got a batch plant and you've got stockpiles for that, or you've just got stockpiles of material that's been delivered, or you're stockpiling topsoil, you could store each of those stockpiles as a different boundary with a different material associated with it. And then you can make a group out of those for reporting purposes, and then generate a volume calculation, which then generates a result that you can look at. And again, the Volumes Manager allows you to come back and look at those results at any time that you might want, and you can always change the volume calculation just by changing a surface here and giving it a new name, and then computing a new result, and then you would have two results for that same calculation. So if you don't want to define new boundaries and define new volume calculations each week, you can just keep rerunning the numbers using a different surface model here and create new results, and still be able to get back and look at all the results that you generate over time. So again, one volume calculation could satisfy all the progress quantities on a project for the duration of the project if you wanted to, just by changing the surface models here each time you want to do the calculation, and then running a new table or a new report onto the drawing here. Okay, so that's the Volumes Manager and the Point Cloud Processor. If you've got any questions, please call us 720-797-8001. Okay, thank you.